Hello everyone. So today we are going to continue that the same topic, that is solution. So we were talking about the solution in the last synopsis also, in the last video also, sorry. So today next concentration term we are going to talk about is that parts per million. Parts per million. So what is parts per million? It is shortly it is also called as ppm. See, when we are going to use this parts per million concentration term means if the solute in solution is very less quantity, then we are going to use this term, that is parts per million. For example, like first we will define the formula. What is the formula for this one, parts per million? Then we'll go for example, that is better. Okay, that is ppm will be defined as number of parts of solute or component present in total number of parts of solution into 10 to the power of 6, that is million. So this is only called as parts per million. So this is the thing. So next, so what is the example we can take? So the example we can take here in NCERT, they given one example, that is see this example, very good example they given here. So what is that example is, they mentioned that in 1 liter of seawater, that is the given weight also, that is 1030 grams of water is there. In that water, so 6 into 10 to the power of minus 3 grams of oxygen is dissolved. See, you can see here 1030 gram of water. In that 1030 gram of water, only 6 into 10 to the power of minus 3 gram of oxygen is dissolved. So in this case what we can do is that, so we can use a parts per million. How much parts per million of oxygen is present in the 1 liter of seawater, that one. See here, this ppm we can represent in the form of W by W percentage also we can represent, or we can take V by V percentage also we can take, or W by V percentage also we can take this one. So let us do this problem. So how much parts per million of oxygen is present in 1 liter of that seawater? See what they given, that is weight of seawater, that is water, is equal to 1030 grams, and weight of oxygen, so they given, that is 6 into 10 to the power of minus 3 grams. So parts per million, it is equals to weight of solute, that is 6 into 10 to the power of minus 3 gram, by weight of solution, that is 1030 gram into 10 to the power of 6. So when I calculate this one, we will get around this is 0.0058 into 10 to the power of that is minus 6 will get into 10 to the power of plus 6. Sorry, this is 3, not minus 6, this is 3. So what we can do means, we can take this one as a 5.8 into 10 to the power of minus 6 into 10 to the power of 6 also we can write. So both will cancel out here. So what is ppm value I got is that 5.8 ppm. It means that, so only 5 in 1 liter of solution, 5.8 ppm of oxygen is dissolved. So this is the meaning of that particular meaning. Okay, that parts per million example. So this is about parts per million. I hope this is understood for everyone. So let's next take next concentration term, that is two more concentration terms we have. Then also we will discuss here. That is one is molarity. Molarity, very important term, that is a concentration term, that is molarity, and represented by capital M, that is molarity. So what molarity says that, so here number of moles will come, mole concept will come here. So you should remember some formulas regarding moles. Okay, let me discuss some formulas about moles first. So moles, that is represented with the small n, that is equal to, if they given the given weight they given and they are asking to find out the moles, then we can use this formula, weight of solute by molar weight of substance, or if they given number of moles, if they given some any volume and then they are asking number of moles, then given volume by molar volume, that is around 22.4 liter or 22.7 liter also we can take according to new IUPAC, that is a representation. So next, if they given number of particles, then given particles by Avogadro number of particles. So these three are very important formulas of number of moles. So now we will take molarity. So now we can take molarity very easily. Now we can understand molarity concept very easily. So how can I represent the molarity in the form of number of moles? See, molarity defined as number of moles of solute particle, present in volume of solution in liter we have to take. Remember this one, we have to take in the form of liters. Okay, so this is a molarity. So and what is the unit of this one? What is the unit? So unit is that number of moles, that is a mole per liter is there, liter. So this is a unit of molarity. And one more thing I forgot when I am teaching mole fraction is unitless there. So mole fraction is a unitless. Okay, so this one you remember, mole fraction is unitless. So this is about molarity, number of moles of solute particles present in 1 liter of solution or volume of solution. How much volume they given, that much volume we have to take that one. So this is about molarity. So we'll take some examples also, don't worry about that one. So then you will understand in better way. Okay, so next, the last, that is concentration term, is that molality, and it is represented with the small m. Remember, so molality, what is molality? Molality is equals to same number of moles of solute present in weight of solvent in kilogram. So this is a molality. Okay, so this is what is the unit of this molality? Unit of molality is that, so mole per kg. So this is a unit of molality. So like this we can represent concentration in different concentration terms. So until now we discussed about different concentration terms, that is weight by weight, volume by volume percentage, weight by volume percentage, parts per million, mole fraction, molarity and molality also. So these all we have to remember when we are going to study about the topic called as a solution. There is liquid solutions. In this chapter we are going to study. Okay, so now we will take up some important problems regarding this one, all concentration terms, so that we will get some more clarifications will get. So let us take some examples in this video only. So okay, see this problem. So I have written from NCERT only. So this is a problem which is given in NCERT. So calculate the mass percentage of benzene, that is C6H6 is a molecular formula, and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of CCl4. So now let me start with this solution. So how can we calculate the mass by mass percentage, W by W percentage they are asking. So now what is formula of W by W percentage? That is equals to mass of solute by mass of solution into 100, right? So now, so what is the given data from that one? So given is that benzene and CCl4 we have to find 22 gram of benzene is there. So weight of solute, that is benzene C6H6, it is equal to how much? 22 gram. And weight of solvent is how much? That is CCl4, it is equal to how much? 122 gram. Then what is weight of solution? Weight of solution is equals to, both if we combine means we will get 144 gram will get. This is the weight of solution, this is the weight of solute, this is the weight of solvent. Now we have to find both mass by mass percentage. So now first let me take percentage weight by weight for benzene, that is C6H6. If I want to talk, that is 22 gram by weight of solution we have to take, that is what, how much? 144 gram into 100 we have to take. So this is equal to, we'll get around 0.15215. Okay, there is this much will get into 100. If I do means it will comes out around 15 percentage. So 15 percentage of benzene is there, and what is the remaining, that is percentage weight by weight of CCl4. We can solve in two ways. One is same formula you apply. Formula if I applied means that is 122 gram by 144 into 100, you can get the value, that is also we can do. Or else, so weight of W by W percentage of CCl4 is equals to, we can do this one now, 100 minus 15 also we can do. That is what is the remaining, because only two components are there in that one. One is benzene is there, one is carbon tetrachloride is there. So if benzene is having 15 percentage means what is the remaining, that is only carbon tetrachloride only now. So that's why 100 minus 15, that is 85% approximately. So this 85 percentage will be the carbon tetrachloride. So this is how we'll calculate. This is the first problem I took. So second one, we'll solve this one also. So that is solution for this one is that, see what they are asking, calculate the molarity we have to find out, molality we have to find out, and mole fraction also we have to find, and they given Ki solution, and they given density. We'll write on what is the given, 20 percentage weight by weight aqueous solution of Ki they given. So density of Ki solution is 1.202 gram per ml they given, and 20 weight of solute, that is Ki, how much they given, that is 20 gram, and what is the weight of solvent, it is 80 gram. Okay, so what is the meaning of this one, you know now already. 20 percentage of weight by weight means 20 percentage, 20 gram will be Ki, and remaining solvent, that is water, will be 80 gram. So now we have to find out molarity. What is the molarity formula? So now only we discussed that molarity is equals to number of moles of solute by, that is volume of solution in liters we will take. So now we have to find out a volume of solution, but I don't know volume of solution, but I know density of solution. Now here I know density of solution, and I know weight of solution also. I know weight of solution is how much, that is 100 gram only. 100 gram is the weight of solution, yes or no? So I know weight of solution, I know volume of solution. Now we can find out the that is volume of solution. Density is equals to what, mass by volume. So I want to know what volume of solution I want to know. So volume is equals to what, volume is equals to mass by density. Mass is how much, 100 by 1.202. So it will comes out around 100 by 1.202, it will comes around, it is 83.33. This is ml we are getting. Okay, so this is the volume of solution I got. Now what is there in that one? So find out the molarity now. So we can find out the molarity. So that is, molarity is equals to number of moles, means how can we find out number of moles? The given weight of solute now, weight of solute is 20 gram. What is the molar weight? Molar weight of Ki, how much? So K, that is 127 approximately 127 plus, that is not K, this is iodine. So okay, sorry, this is iodine's molar weight. And what is the potassium's? That is the atomic number is 19, and it is around think 39. Yes, it is a 39. Yes, so both if I calculate means we will get 169, that is 166 approximately. Okay, this is the molar weight of Ki, that is 166. And how much volume we got there? Volume we got 83.33 in liters. If I am having 83.33 ml means in liters it will be 0.083. So this is a volume. So we will get approximately this molarity after calculating all these things. You calculate yourself. Okay, so by calculating all these things we will get around 1.5 molarity, that is mole per liter. So we will get this molarity, and this is the first answer we got. So second, what we have to find? We have to find, it is molality. Molality is also same, we have to find, it is, what is it? number of moles by weight of solvent we have to take now. So 20 gram by 166, that is molar weight of Ki, into, why I am doing into, because the formula is this one only, na, molarity is equals to number of moles by weight of solvent in kilogram. So what is weight of solvent? We'll check here. Weight of solvent is 80 gram. Okay, so now that is 0.08 gram I can take. So now molality also will come approximately, see here 0.083 is there in molarity, here weight of solvent is 0.08, approximately it will comes around 1.4. see here, one thing you observe that, so for same solution, if we are calculating for a same solution, for note point, for same solution, so molarity is always approximately equal to molality, both will be same always. Okay, both will get same value only. See here, approximately 1.4, not 1.4, more than 1.4 also it will come. Okay, so now it is having here we are getting, that is molarity also 1.5 approximately. Okay, so this is the value we have got here, and one more thing we have to find, that is mole fraction. Mole fraction of the solution. What is mole fraction? That is chi, it is equal to number of moles of two things only we having, that one is Ki